Okay, there we go. All right, so this is the second day, and actually it's the last day that we're going to cover parabolas. So on Tuesday when we come back, we're going straight into the ellipse. So absorb as much as you can here. For number one, this is a new type of example. It's actually one of the homework questions. It's actually number 35 in the book. And tonight, for your homework, you got 25 through 41. So I'm actually doing one of the problems for you here, okay? So write down the important information that you need. We're going to find the vertex, the focus, the directrix. We're going to graph this particular problem. Okay, does anyone notice something right away that is not quite right? Yeah, what do you see? No, not yet? Yeah, what do you see? There's no parentheses. Okay, yeah, what do you see, Michael? It's not in a standard form that we can actually find information at, right? So who remembers what the trick is? I told it to you yesterday. You want to go? Yeah? Yeah, you have to complete the square on which term? The squared one. Exactly. So that's exactly what we're going to do. So we're going to say y squared minus 4y plus some magic number here has to equal on the other side. We're going to go negative 4x minus 4 plus that same magic number, whatever it happens to be. So remember, this is our magic number here. And we're going to add it to both sides. Okay, who remembers what it is and how do you get it? Daniela? It's 4. How'd you get it? Yeah, you take a look at the b coefficient, right? Negative 4, half of negative 4 is negative 2, and you square that, so you get 4 there. So whatever you add to one side, you got to add to the other side. Okay, now this is the most important part. Who remembers what does this break down to? Perfect square trinomial, correct, and what would that be? You got it, yeah. Y minus 2 quantity squared equals, oh, look what happens on the other side. We just get negative 4x. There you go. Now we're in good shape. So, where is the vertex then? 0, 2. Yes, you guys got it. 0, 2. Why is the 0 there? Yeah. There's no k term, right? It's just negative 4x, okay? And then, of course, the 2 is we switch the term around because it's in the form of the standard equation. We have y minus k. Okay. Now that I know this information, I need to find the vertex, what else? The focus, and then the directrix. So let's go ahead and start to graph this thing and see if we can get some information. Which way does this open, by the way? No, this opens left. How do you know? Because the y is squared and the coefficient is negative. So this opens left. So the vertex is at 0, 2. 0, 2. Here's our vertex. How do we get the a value here? Anyone see it? Yeah, what is it, Ian? Anybody? What do you think? Yeah. Yeah, so what we do is we look at this stuff. We look at the stuff in front of our x term, right? Because this is how it's set up in that equation. So we go, okay, let's set negative 4 equal to 4a. So a has to be negative 1. So interpret that for me. What does a have to be when it says negative 1? What does that mean? Interpret that. Yeah, what do you think? Yeah, we know it opens to the left, but I want someone to interpret the a equals negative 1 part for me. Yeah. Yeah, that means just go 1 unit to the left from where? From the vertex, right? So here's my vertex. So if I go 1 unit to the left, there is my focus. So now my focus has to be at, what's the coordinate for that? Negative 2, or negative 1, 2. There you go. Negative 1, 2. So vertex, focus. Easy enough? Okay, I'm not done yet. What do I have to do? Directrix. So what is the equation for the directrix? You got it. It's back here, right? This is the line x equals 1. Good. There's my directrix. Put a D there for directrix. And I need my lattice point so I could easily graph it. And how can I find an easy lattice point? You got it. If I go 1 unit to the left, so A is 1 unit, let's go 2 units up. That puts me there. And 2 units down. That puts me there. And that's enough information to make a quick and accurate sketch of my actual parabola. So please be sure you have the F, the V, and the D located. That's what they want you to do. Okay, this is like the second box. This is just like the quick start, except I have taken something away. What have I taken away? The focus point, yeah. So go ahead and make a sketch of that best you can on your graph paper. And the question for us is, write the equation for the parabola. So you're going to be given some parabolas, and they're going to give you some information inside on the picture. You have to decipher it and then turn it into an equation. Graph right there. Anybody know anything about this that they could share with us? There is something that we know for sure. Yeah, what is it, Michael? Yeah, we know the vertex, right? And in this case, is the vertex at the center or the origin? No, it's not. So we know we're going to have an H and a K somewhere in there, right? So that means that the 1 for us represents the H, and the 2 represents the K because this is my vertex. Okay, so what equation am I going to use? What's the standard form for an equation that opens down, vertex is somewhere else? Yeah, Benny, what do you got? There you go. So we're going to use this form and plug some stuff in, right? We know what H and K are, don't we? Yeah, so we can plug that in right away. So we're going to have this. We're going to have x, let's see here. H is a value of 1, so I'm going to have x minus 1 squared equals negative 4a times y minus 2. You guys agree with that? All right, cool. Am I done? No, I'm not done. I have to do a little bit more work to figure something out. What do I need? I need the A, don't I? And here's a question for you. Do you know this point right here? Is this that I've highlighted, is that a lattice point? Yes or no, and how do you know? Yes. What do you think?
Because it crosses the same corresponding point on the other side of the vertex.
Okay, so if I were to draw a horizontal line here, how far down would this be? How many units is that? That's 1 unit down. How many units over is this? 1 unit over. So is that a lattice point? No. What would make it a lattice point? If it was how many units over? Yeah, if it was 2 units over, then it would be a lattice point. So this is not a lattice point, so we have to do a little bit more work. So how do we use this point to help us out? Anybody got an idea? What do you think? Yeah, it's exactly right. It's as simple as that. This represents the x. This represents the y. Holy cow. This represents the y. So we're going to plug those in. X value is a 2, goes right there. Y value is a 1, goes right there. And we figure out the A. You ready to do it?
Yes.
Okay, here we go. So I'm going to have 2 minus 1 squared equals negative 4a times 1 minus 2. All I did was I substituted x and y into that equation. So that's going to give me 2 minus 1 squared, so 1, equals negative 4 times a times, what's that? Negative 1. So I get 1 is equal to 4a, so a must be 1/4. Awesome. Am I done? No, not done. What do I do with that information? Do I graph? No, I don't graph it. The graphs are there. I have to just find the equation. I plug it in. Look at this fun line right there. You see my awesome arrow there? So when I'm all said and done, my answer is this. X minus 1 squared equals negative 4 times a 4th. Well, that's just negative 1, right? So negative 1 times y minus 2. And that is the answer. What do you guys think about that? Yes? Yeah, we should put this thing on a graph, right? We have the satellite, let's put it on a graph. So what if I did a cross section of this thing, right? So what if I did this, and I was like, and I cover the shape right here, right? Do a cross section. And then I do have an axis of symmetry that goes straight down there. How do I set my graph up to make it easy for myself? Who's got a really good idea? Where's the vertex of this thing? Yeah, let's put the vertex down here at 0, 0, right? So if I'm going to make a graph, if I'm going to make a cross-section, let's make it easy on ourselves. Here's x, here's y. Let's put our vertex down there at 0, 0. And which way do you want this parabola to open? Up, right? Most satellites point towards the sky, last time I checked. So let's make sure this thing goes up. Okay, how can I put this stuff on the graph? Can someone give me 2 points? What would this point be over here?
6.6.
No, the 6.6 is all the way across. So this would have to be 3.3 comma what? 1.2. Why is that the case, you guys? Because this satellite dish is 1.2 feet deep at its lowest point, right? So this distance right here is 1.2. You guys with me? So what am I'm looking for? I'm looking for A, which is the focal point, right? So this represents for me an X. This represents a Y. So what equation can I use? That's it. This is x squared equals 4ay, man. That's it. X squared equals 4ay. And what's our goal? Find A, because that will tell us where to put what? The receiver. You got it. All right, here we go. What's the value of x I'm going to use? 3.3. So 3.3 quantity squared equals 4 times A times what's the value of y? 1.2. You guys with me? Makes sense now? Yeah, kind of. Okay. So what's 3.3 squared? Someone help me out. 10.89. Thank you. 10.89. 4 times 1.2 is 4.8a. Okay, what do we do now? Divide 4.8. Divide 4.8. So a must be approximately... Come on. 2.27 what? Elephants? Monkeys? What is this? Feet. Yeah, so interpret for me. What does this mean? 2.27. What does that mean? Someone interpret for me.
The distance from the vertex of the parabola of the satellite.
You got it. So that thing should be at about 2.2, what was it? What was our answer? 2.27 feet above, so that all the information can be bounced back to the correct spot. So when you look up here, this must be about 2.27 feet above. How cool is that? We can actually do something with this. Yeah, pretty sweet, right? Yeah. All right, awesome. Let me stop this.